Hello, welcome to the ConTech Live weekly webinar. I'm delighted to welcome Dr. Leslie McIntosh, who is the CEO of Ripeta. Leslie is going to talk to us about making better science easier. Fascinating topic. Just to explain, if anyone's not been to a ConTech Live webinar, we run for about 30 minutes. We are using Zoom webinar. Your mics are currently muted, but there is a Q&A button at the bottom. Please feel free to file those questions as we go through the presentation, and we'll wrap up at the end. Leslie McIntosh is currently the CEO of Ripeta. She's also the inaugural executive director for the Research Data Alliance, which is part of a global organization developing recommendations for data sharing and interoperability. Again, really important issues for the ConTech community. In this presentation, Leslie will talk through recent improvements in scientific publishing, specifically highlighting how policy affects practice and how to simultaneously increase the speed and accuracy of quality checks. That's all from me. I'll join you towards the end when we wrap up with the Q&A. Just hand over to Dr. Leslie McIntosh. Leslie.
Thank you, Clive, for having me. I really appreciate being here. Let me just make sure that it's sharing. And there we are. So thanks again. I'm Leslie McIntosh, as mentioned, the CEO of Ripeta and also working with the Research Data Alliance. And today I'm going to talk about making better science easier, or how we're attempting to. And let's start out with just open science. So open science is great, but it's hard. So one push with open science has been to have data availability statements with research articles. And this has been in policy, this has started in practice, and this should help with data sharing, but it falls short. And there's different ways that authors say they share data. We have 7 categories, which I'll show you. And one category is data available upon request. And I want to explore that a little bit more, because this is how policy also then affects practice, and in ways actually that it does, in ways that it doesn't, and explore what can we do about the fact that data still really aren't available, either not when you need it or never. So what can we do? And let's explore that during this talk. So let's start with transparency as a solution. And open science ties into reproducibility, which ties into transparency. And I would say that transparency is where reproducibility begins. It can be thought of as the sufficiently clear and complete documentation of the research. Now, this is distinct from accessibility, which requires information to be available as opposed to the process of being transparently described. And so while not all research materials need to be accessible due to confidentiality or anonymity, achieving adequate transparency is essential to reproducibility. And this is also vital to improve the quality of science. But what does quality look like, and why is it important? So let's look through the lens of a scientific publication. There are quality indicators for which trust is built, and these aren't necessarily explicit statements or guarantees, but a footprint of trust, if you will. So for example, to quickly judge if a researcher supports reproducibility and responsible research, I look for a few key items in an article or a grant. So use of a unique author identifier like an ORCID, a well-stated hypothesis, data availability statement and data sharing, citing data, sharing code, and the like. So if there's, for instance, a data availability statement, but all it states is to contact the author, I'm going to have less trust in their work than if they have given specific instructions for obtaining the data or a link to the data. So that's an idea of tying reproducibility into transparency and into trust in science. But let's look at these core components of reproducibility, which they really boil down to data, code, and software. There's certainly more that tie into trust, but I'm going to focus on that. And then really tie this back into policy, which is one place that the scientific community has made great strides, is in requiring data availability statements. So let's explore how this is going. So let's look at find the data. data availability statements have been growing within publications and publisher and funder policies for a number of years. And this is really to help make data available. So let's look at ways that that's actually happening in practice. So one is you'll see something such as this, a data sharing statement, a data availability statement about data sharing, and it says upon request without justification. And as you can see here, I'm not sure how you would actually get the data. Because, and we'll talk about this in a second, because of contacting somebody through email. There's also this subtle difference, though, that is a justified reason for saying that the data is available upon request. And by the way, those aren't the real emails. We did pull these from a real article. But that is because there are certain privacy issues that need to remain in check with the data. So it gives you an example of how a little bit complicated data sharing can be and data availability can be. But the fact of the matter is, when somebody says that data is available upon request, I'd actually argue that the data are not available. So if we can get the data, what kind of data are we talking about? Raw data, summary data, questionnaires, which all are important, and it's very important to know what you are searching for. And what about this email thing? Emails get outdated and sometimes aren't even real to begin with. So they also present barriers. We could be honest about two things. Having to request data creates gatekeepers, and gatekeeping will have biases. And the second thing is, which researcher do you know that really likes to answer emails? And I speak as someone who was a practicing researcher for many years. So that's why I would argue that the data are not available. But let's look at what some of the research shows. So in this Cell paper, it talks about, they examined the availability of data from 516 studies between 2 and 22 years old. And the odds of data existing fell by 17% per year. There were broken emails, obsolete storage devices, things of the like. So the odds of being able to contact the author fell by 7% each year. Again, supporting the idea that maybe saying that data available upon request is not really the best way of doing things, but it is one of the easier things for researchers to do, and we need to think about that. So it's easy, but it's not better science necessarily. So what are some ways that people can share data and are sharing data? Here are basically the 7 buckets we use. Lisa Federer has done research and published on this as well, along with quite a few others. So the most available of data would be in an external repository, and then saying that the data is in the article and supplementary files, which researchers are doing as well. To give you an example, as the second best, it still might not be the data that you need, but at least you can make a decision about it if the data can be accessed in the supplementary methods. But another example the best that we see so far right now is data sharing in an external repository. And I will say that I'm highlighting data sharing and not code sharing. So that's a little bit different of a talk, but happy to answer any questions about how to make that easier, because there are some great companies doing that. So let's explore what we're seeing. And this gets back to policy versus practice. So DAS's data availability statement, and why that doesn't equal data availability, even though these policies have been in place for many years now. So looking across 5 journals that have data sharing policies, we looked at the percentage of articles within each journal that had data availability statements. So they all had policies, and 2 of these actually enforced their policies a little bit more than the others. And you can see the results. Those are journals A and B, and you can see the results from that. What happens though is there's actually not a greater compliance, just to let you know, in having data availability statements present when we correlate this with, or try to correlate it with, an impact factor of the journal. We also then looked at, could you actually get to the data? And this is the same journals in the same order that have the percent that have data as public or listed in a specific repository colored by impact factor. So again, there's no correlation by impact factor, and unfortunately the data still aren't available even though the policies have been in place and there is more agreement among researchers in many communities about the need to share their data. So how do we fix this problem and who takes responsibility? This is where I posit that we have to make better science easier. So let's talk about improving quality and improving efficiency. We believe, this is at Ripeta, that improving the quality will improve efficiency, and automating what we can will improve the speed of science. So we believe that the scientific community needs faster means to check and improve science. So as we as a company build new algorithms to speed up the process of scientific review, how do we build in and assess trust in the automation as well? Let me quickly take you through our process. The first thing we did was we developed a framework based on existing guidelines as well as personal expertise. And then we looked at and reduced them to critical variables that we, from feedback, felt like or know that would move science forward in reproducibility, and also things to balance both researchers' needs and publishers' needs and funders' needs. So I'm just going to pick on this article as one, but I could, and I'll give a few others as examples. But what we do is we look at an article and we look for something such as, is the study purpose stated? And we find, it doesn't say this is our hypothesis, but in this study, and pull out that information. So yes, the study purpose is stated here. Then look for data availability. Yes, in this case, we're not telling what type of data, and as you can see, these are raw data, but we are pulling that out. We also look for whether the software is stated, the version of the software is stated and cited, all very important for reproducibility and for good science. And we're also looking for code availability, but in this case, it was not found. Now, I showed you this manually on how we do this, but we've automated the process through AI to develop algorithms to pull these out and then present a summary report. So let me now take you, that's kind of how it works, but let me take you through what's very popular right now, unfortunately, is in our pandemic COVID-19 articles. So we looked at, in March 15th, there were 535 preprints on medRxiv and bioRxiv. And we wanted to run them through our system to see how they did with our analyses. So, and oops, wait a minute. I will talk about each 4 of these papers, but here are the DOIs. So basically, we run them through our analysis to see if they had a study purpose, the authorship, which is what type of email they have, and do they have an ID, an ORCID. With that, funding statement, data location, data availability, I can't say it now, a DAS, and code availability. So the first one, the uncanny similarity of unique inserts into the 2019 nCoV spike. This one, if you look at the analysis, our Ripeta analysis, which is just this is pre-peer review, but unfortunately it did not do well. It did not score well on the Ripeta analysis at a first pass because of the lack of funding statement, data location, DAS, and no code availability. And in fact, this one was already withdrawn. Again, these are all preprints. They did not go to peer review, but because they were COVID, they started getting a lot of attention in the media. This one, I think we all know by now, on hydroxychloroquine. This one did not do well either on the Ripeta review in the first place. And so it was flagged for a closer look. Elizabeth Bick, unrelated to what we were doing, did take a closer look along with quite a few other people. And this one was highly questioned. And I think at this point, we're still not recommending hydroxychloroquine to take for COVID. So that was questioned. The next one, this one, interesting. It got a lot of media attention, the relationship between ABO blood groups and the COVID-19 susceptibility. This, again, is a preprint. It didn't do too bad on our review and thought it could be improved. Unfortunately, it got picked up by the media and way overhyped before it went to peer review. So it was just an overstated impact, but I honestly felt quite bad for the authors, because it's not a bad, it's not bad research. It just really got picked up and overhyped. But then the last one, which did and does correlate quite well to how it scored on the Ripeta analysis, and this one has done quite well and was published. So I think that the take-home message that we want to do on that is part of this peer review, part of this pre-peer review, excuse me, is that it needs to go quicker. This COVID was a great example of why it needed to go quicker. We needed to get the science out. We started scoring things on these publications. We'll have a publication on this out very soon. Our preprint's already out on it, about how well these are doing, when and if they've been published. But just to give you an idea, we could quickly scan these 535 preprints, and it would take 43 hours to manually do it, and it took 5 minutes to be able to go through these. Now, so this saves time while checking the quality. And this is what we're doing to improve research. It's really one place in the bigger challenge of improving the speed of science by checking for the quality of scientific reporting. But this is the movement to make science fast, open, and checked. And because what we really want to do is make better science, we need to make better science easier. And that's what we're trying to do. So that's really the talk. I left hopefully plenty of time for Q&A to go through this. I just want to point out that I have a wonderful team that works with me on this. Cynthia, my co-founder, Ruth, Chris, Leah, Sarah, Paola, and Josh. But open for questions now. Thank you.
Thank you, Leslie. That was a very engaging and very interesting coverall of a very, very important topic, I think. So let's move to some questions. First question we have is, do papers tend to have all or none of these quality measures, or is it hit or miss? Why do you think you found the trends that you have?
It's definitely hit and miss on these quality measures. The least likely to be on there out of the ones that we're looking at is going to be code availability. But I'm kind of working backwards. If people tend to share their code, they either share their data or they share some simulated data in case they can't share their own data. They tend to cite their software. They also tend to have ORCID IDs. The interesting thing is some really good papers don't have clearly stated hypotheses, is what we're finding, which I find a little bit interesting. And I think that's because they just haven't tightened their hypotheses, even though they've tightened a lot of their methods.
Yeah. Okay. Does this truly do anything to make better science easier for the researcher? This is a slightly unfair question, given the name of your talk. Or is it just making the peer reviewer, journal editor's job easier?
Yeah, I think that's a tough question and a fair question. So what we've had when we've tested this out with researchers is it was able to give them a quick feedback on how to improve their science. So one example, I was working with a postdoc and she said, I really thought I did well, but I didn't have a clearly stated hypothesis. So she went back and she actually, she improved her paper. She also did a better job of sharing her code before she sent it to publication. So certainly it could help with the review process. In this case, it was interesting because she got that out as a preprint and then had people calling her and ended up getting a job offer. So I will say in this case, it did help her, but I think there is also the opportunity to get these out to help the pre-peer review process so that we can get them to peer review.
Sure. Even if these variables improve speed, quality, why focus on these ones specifically? Don't journals have numerous quality guidelines that authors are supposed to adhere to?
Journals definitely have numerous measures to over 400 that when we counted, and we tried to look through what was going to be the minimal amount that could move science forward towards reproducibility and towards better science. So there's a balancing act with this, in that there are numerous, and I would say that these are necessary, they aren't sufficient. We can't prove that the research would be reproducible with these, but writing a paper and doing researcher, I know as a researcher, it's very overwhelming, and there are a lot of things that you have to adhere to. So what are the few things that we could do to improve science now? And that's really what we've tried to hone in on. And that's why checking for data availability statements and where people are sharing data has come to the forefront. But we're also looking at code availability, because it's very important, when you're trying, for those that use code for analyses, that it's there to make things reproducible. It's not really required by publishers for a lot of publishers. In some fields it is, but not all. But to your question, we've really honed in on how to make science better by making it more reproducible and by not overwhelming the scientist. Because
Sure.
in my heart of hearts, I know how hard researchers work. And I know how overwhelming it can be. So that's why we really focused on a few. And then we'll add more over time as some things become normal.
Okay, interesting. And what is the difference between transparency and reproducibility? Which is more important for determining paper quality and trustworthiness?
I think the best we can do on a lot of fields, and given I do come from the biomedical sciences, so I'm come from a space where you couldn't share a lot of data. I think that transparency is extremely important. And it's not being able to reproduce the results, but it is being able to know the steps that people took in doing the research. So there's a balancing act. And I'm just gonna, wasn't really in the question, but I'm gonna answer this anyway, or make the comment that, you know, there's still controversy or discussions about reproducibility and do I have to make everything accessible? But the truth is, most researchers need it for the next postdoc or for the next person that comes through within their own group. Mm-hmm. So it's really important to make that whole process transparent to yourself and transparent to your group to save that time and to be able to continue the research.
Yeah. A personal question for me: how do you connect with your main users? What is the process for making sure people are aware of your ability, your capability within Ripeta?
Yeah, so where we're working right now is more on the submission of articles, some with preprints and some with journals. What we found when talking with honestly a lot of my colleagues from biomedical sciences and doing user testing is that what researchers want is very few places to go to have to check their manuscript. So it made more sense, instead of working, even though I still work with each, all the users, the researchers, I'm sorry, it's better to actually work with platforms that bring in manuscripts, because the researchers don't want to have to go and find different things, because there's other things to check for, such as, language checks or, grammar checks from a scientific standpoint, and to go into one place. So that's really where we're working and focusing our attention right now. Wow.
Leslie, that's fantastic. That's really interesting stuff. If we get any further questions, we always will try and connect with our presenters after the fact. But thank you so much for that presentation. For everyone who's attended, we will produce a recorded, transcribed, and indexed version of this webinar that will be available in about a day's time. That'll be available on our website. We'll also share that with Leslie, so she has it available too. Next week, same time, 4:30 BST, we are looking at knowledge graphs, and the webinar is entitled "Why Knowledge Graphs Are Important for Scholarly Publishing." So if you haven't already registered for that one, that's going to be presented by Harris Dindo, who's the Chief Data Scientist from UNO. So another really interesting topic to look forward to. So all I need to do now is thanks everyone for attending. Thanks again, Leslie, for a fab presentation. And I hope you all enjoy the rest of your day. Thanks very much and goodbye.
Thanks so much.